StarPath, School of Navigation in Seattle, Washington. The note here will be about plotting a bearing fix in OpenCPN. We had a question come up actually 2 days ago to illustrate a bearing fix plot on OpenCPN and also a running fix. And so I'll do this in 2 steps. First, we'll do the bearing fix, and it brings up a few peripheral things to think about with regard to using the e-charts. And so we're going to do this with a training chart, 1210TR, and let me show you. This is our textbook. That's a little plug for that. But for our textbook, we have several workbooks. This is a workbook we use in our course, which is a training chart of the Pacific Northwest. This is a training chart used in the East Coast of the U.S. very much, and that's the one we'll use as an example, this training chart here. And then using chart, let's see if this goes here. That goes to the chart. Then the StarPath chart exercise. Here's where you can, okay, so here's a place we set up and where you can download the chart. I'll put this in the discussion, but you can download here various things, PDF of it. Here's a high-res VSB RNC. It's an RNC chart of 1210TR, and this is one we made from a large scan of the training chart, and that's the chart we're going to use today. So I don't think I need this anymore. And let's look in our ebook. This is an ebook copy of that textbook. And here's a problem we'll do. A hand bearing compass, you measure a bearing 107M magnetic to Gay Head Light and 084 magnetic to the monument on Cutty Hunk Island. Where are you? What's your lat lon? Okay, so in another video I just put up recently, we illustrate how to do this trick. Look here, you click. This is a plugin called the Object Search Plugin, and again, we have a whole video on how to use it. And we can put Gay Head Light in case you don't know where that is, and that would be, you see here, and then you just show it on chart, and there's Gay Head Light. So that works really well for areas you don't know the chart well. And then we have, what do we got here? Magnetic bearing. Okay, so let's get back in gear on that. Go to the wrench. We got to be sure we're in the right bearing. And let's see, display, units. Show true bearings, show magnetic bearings. This is showing both. If you're going to use all magnetic, it might be cleaner to not show both, but just show the magnetic. And this is fifth. Okay, so here's the issue with this kind of training chart. This training chart, like most of them in the U.S., were frozen about 1990 or so, a long time ago. So on all of these charts, the variation has changed. Back in the day here, the chart had a variation of about 15 degrees in this part, 15 degrees west. And so we just recommend in our workbook, and all of our problems are assigned that way or given answers that way, you assume the variation is exactly 15 degrees west. It varies maybe a half a degree across the full scale of the chart, but we're going to always use 15 degrees. So that's where you do it. There is a plug-in. Let's see if I can't tell here. But there is a plugin. There's a real nice plugin called World Magnetic Model, WMM plugin. That has to be shut off, and we just put in here the 15 degrees that we want and say apply and say OK. But let's not stop there. Let's just check that. Now, and here's another reminder. Again, a few little notes about this before we get to our actual plotting. But I could use the M key and then just go like along here. And then go to, you see, that's 285. That's exactly right, because we're correcting at east, so we subtract west. And so 285 minus 15 is 270. So we're okay on that, but then if I hit escape, it goes away. But you see, you can't, these don't stay. If I actually want to keep something on the chart, I can't use the M key. I've got to use a route. And then I could say here, then it's going to try to go somewhere else, and I just say escape. But now I have this line drawn here, and it's permanent. It's a one-legged route. Okay, right-click properties. Oh, I don't need it. Here is the bearing 285 magnetic and so forth. Okay, cancel. I don't want that. We're just going to say delete. Okay, so that's that. Yes. All right, so now we're ready to go. We got a gay head light. Now the other thing too is this really, I have to say here, this is a textbook problem. This is a light that's visible from 17 miles off, right? So let's say maybe the light's on and it's dark. You'll be able to see that light 17 miles off. But 17 miles away in the daylight, you probably wouldn't see it at all. Not at all. And so likewise, either this light's on and then you won't see this other thing, or and so on. So it's a little bit, keep in mind, these are textbook problems, just so you have practice doing fixes. These aren't realistic. Now, the workbook we use on the West Coast over here, most of our problems are with it a little more realistic. But that doesn't matter whatsoever when it comes to learning the technique of how to do the plotting and problem solving. But so if we're going to do this electronically we have a potential to do accuracy, but we just have to be a little bit careful. So we're going to start here. Now we come across your first problem you come across with OpenCPN. See, in some programs, like for example Coastal Explorer, you could go here and you could draw a line in direction 287. What are we after here? No, what are we after? 107. See, you could draw a line in direction 107, something like that. Let's say that's 107. And you could draw that. Then you could grab that whole line and move it. Just like you're doing parallel roll, you could grab this line and move it. Now, some programs do that. Coastal Explorer that's a Rose Point. That you can do it, but that's a $300-400 program. Let's delete that. So, but we have other ways to do that. We don't have to do it that way. So, first of all, if you're just let's say you're pretty close in here and you want to draw a bearing that you just did. One trick way, and you don't have to get out a calculator, is you would just go up here, take your bearing tool, this guy, and put a dot here, right like that. Then go in, and that's obviously not where we are, but you go into 107 magnetic, which is about, now here's another, it's hard to see these numbers here. Oh, there you see a little bit better. You see that 107. Here's 106, 105. There's 106. I'm in too close to show this point here, but that's 106, 106.5, 106.8, 106, 107. So you can actually see the whole degree. So 107, sort of right when it first turns from 6 to 7, that's there. And if we were a little... Okay, so that's 107. So then you could just drop a point there and then just take the route right back where you were that way, you see. That's another way to draw. Now you've got a line as if your boat were, as if your boat were out here and you were looking at 107 and I didn't have to do any arithmetic. Now, that's one way to do it, but in a case like this where we're somewhere out here, probably, I think in this problem, that's going to be maybe not as accurate as we want. So let's delete that and do something a little bit slower, and that is if we're looking here in direction 107, then that means that looking this way back at the boat from the boat to the light, that was 107. That from the light to the boat then is 287. 287. So let's just zoom in here so we get started at exactly the right spot. Start your mark, put it right center here. Not here, not just randomly around there, but right exactly on that dot right there. Oh, I even missed it a little bit. And then just you come out here. Now you can do two things. You can roll the mouse, that changes the scale, you see, and then you see at the end, you see out here at the end, it's showing the range. It's showing the range. I mean the bearing, the bearing, 291. So we want 287. So here, look at this. That's 285, 286. Now it goes up, and I'm moving slowly up. I'm just inching the mouse up, see? So there it went 86 to 87. Now if I were not careful and went fast, I could have 87, see, clear up here. So I want to come down, come up to 286, and then just when it, bang, right there, that's 287. Let me come out here. I forget where this fix is, but let me just come out a little bit further here and say 287, 286, 287, 286, right there, bang, that's it. Now I can just hit escape. That's my first LOP. All right, now what's the second one? The second one is at Cutty Hunk Island. So again, let's say I don't know this chart at all. I'm just starting from scratch. C-U-T-T-Y Hunk I-S Island. There. That's it. These are all the same. There's various things on the chart named Cutty Hunk, and every object that's on the chart that has a name is listed here. And you have to see the other video about how to do it. Show it on the chart. All right, so there's Cutty Hunk Island, and we're looking for a monument on Cutty Hunk Island. Now, that's almost certainly it. M-O-N, that's probably it. But let's suppose you're insecure here about that M-O-N. Maybe that's Monday. I don't know. So what you can do, short of looking it up in the Coast Pilot or the Light List, a trick is just look at the ENC chart. That's the electronic navigation chart, because these charts are effectively the same. See, here's the thing right here. You see right here. If I go here, well, it changed the scale a little bit, but anyway, here's the object right here. Now, if I just go in here and right-click this, I'm in OpenCPN, so I right-click, I get an object query, and that's the way the ENCs work. And well, look at that. I don't have to look very far. It's a landmark and it's a monument, right? That's the type of landmark it is. And I see it's visually conspicuous. That's good. Almost certainly not visible from where we're pretending we're seeing it. But anyway, so that's just a use. That's not the subject at hand. It's just a reminder that the ENCs are basic, have almost all the Light List data in them. Plus a lot of the Coast Pilot data is buried right into the object, the attributes of the object. Okay, so let's now start here at Cutty Hunk Island. What are we going to? Cutty Hunk, we're going to 84. We're looking at 84, up 84 to the island. That would, to the monument. That would be back down 264. So let's start another line, get right square in the middle here, and go down. Let's see, I've got to at least cross that other guy. Where is he? Oh, here's he. Okay, here's our other LOP. So I want 264. I have to come over here some more. Oh, look at that, 264. This is going to bring up a good point. Okay, 264. Now again, there is 263. See, the farther away, the bigger that the bigger distance 1 degree is, right? And so this is like 263. There you go. Look at that. 264 is right. 264.0 is right here, right? Now, then you go up, see, 64.5, 0.6, 0.7, 0.8, 0.9, whatever, on up to, there's 265. So that's something to keep in mind. It's a huge factor when you're this far away. Again, we're far enough away that you won't see it. And I'm going to call that right there as a mark, escape. Okay, now we come back to an interesting point about OpenCPN. Once I've got to draw my line out further, but first of all, you got this point. I can't move it. That's the default. You can change that, but the default, so I can't move it. So what the first thing you have to do is look at the waypoint itself, look at the properties of it. You don't have to do anything. But then once you have the properties, you can move it. Right now I can move it. But look at this. I no longer have I don't have my information on it anymore. You see, I've lost it. So if you don't make it long enough, you really almost have to start again. There's ways to hunt and peck, but I would just say you escape, you come down here, you come down here, click the line, and delete it. Delete it. Yes, and start all over again if you want to. Now again, I'm talking and doing other stuff at the same time, and so that makes it look like this is a lot longer process. It's actually a very fast process to draw 2 bearing lines. So what do we want here? 287. So I'm going to start again. This time I'm going to make it long enough. I try to get right on the dot, and then I come out here. And if I want to, I could roll the chart in. I'm on a mouse. I'm rolling the chart in. Now I want to roll it out. Let me go back out. Well, roll it back in a little bit. Okay, so I got to go here, but I want 287. Right at, oh gosh, the other one too short. Anyway, it's about there. Okay. So there then is the fix right there. And so there's different ways to do that. I can see down here is a lat law, and I could read that. But let me show you. I still have this thing open. I don't need that. I could read, in other words, let's say I want the answer now to right here. And I could put the mouse right here, and then down on the bottom here in the status bar, read the lat lon. But usually something like this, it's easier to do is to just drop a mark on here and then read the properties of the mark. Well, here's the first thing you find out. If I right-click here, it says I can drop a mark. But if I go over here and try to drop a mark right where I want to, there's no way to drop a mark, right? Can't drop a mark because it's right on that line. It's right, in fact, right on 2 lines. So just go up here somewhere off of the place a little bit, drop a mark. Once you drop the mark, then you can zoom in and pull that mark down. Whoop. Same issue as before. You can't move it unless you're showing the properties. Okay, so let's do that. And that's not. Now again, you can shut that property off, that property of the properties. You can shut that off, but I wouldn't do it. It's very nice to, when you make a mark or you make a leg of a route, you don't want that moving accidentally, and these things can move accidentally. So there's nothing wrong with that kind of inconvenience. Okay, so now I have a mark right on the spot, and you see now I can read here the latitude and longitude of the fix. Let's see my fix, say, whatever. Okay, now there's the latitude. I'm reading latitude, longitude, fix. Now, I have to hope, after all of that we got the right answer. Now, what do I do? Let me go back to the book, and I think I put a mark on the answers. No, that's the running fix. I'll do that in another video. Running fix is a little bit different. Okay. Oh, all right, so here's the answer. Let's see, how am I going to do this? I want to show them both at once. I guess I could. There's the answer. Oh, well, how am I going to do that here? Well, let me see. Hang on a minute. I apologize. Okay, there's the, well, I'm going to read the answer off. Well, here we go. That's pretty good. 4121.4, 21.406. Okay, that's good. And longitude north. Longitude 7108.9, 7908.97. Okay, so we got the answer right. So that's the job. That's step 1, and that's good to know. That's a long video. But let me just show one other thing. I want to show our StarPilot. If you want to actually calculate, one of these bearing fixes, let me see where I have that. Finder. Here it is, right here. So what you would do, here is a function of our StarPilot calculator. It's a navigation calculator, and it's just one thing one of the things that it does. It's a state-of-the-art celestial calculator, but what's often overlooked, too often, it's a state-of-the-art piloting calculator too. And the way it works here is you put in the latitude and longitude of the first target that you looked at. There's a first target. That would be like the gay gay headlight, and that would be Cuttyhunk Monument. And the bearing, bearing A and bearing 292. What is that? Bearing A and bearing B. Well, I'm going to have to come back and figure that out. That doesn't, I wonder if that got changed. I worked this out and copied it, and sure enough, I have the right answer here. Well, I'm going to let that go. I have to let that go for now. That's somehow, I don't understand that. This should be the bearing that we did. No, I've got it. Excuse me. These have to be true bearings. These, in the StarPilot, we're always using true bearings, and the variation's 15 degrees. That's what the issue is here. So that's a true bearing and a true bearing, and then you get exactly the same, you get the same fix, but here you just computed it. And the only thing you would have to do to use this is you'd have to know the exact, precise latitude and longitude of your target. And the way that you would get that, typically the best way, I mean, you can always go on any kind of chart like this and put your mouse on it and read it down here or something, but you can't copy and paste this. So what you would do is go back here to the, go to the ENC chart, go up to the light, right-click, query the object, and right here you see you can cut and paste, Command-C or whatever, Control-C, you can get the lat long of your target. Then that you just paste into the StarPilot, put in your bearing, and it'll compute the fix. Anyway, I just wanted to put that little plug in there for that tool, which is a very powerful way to solve these. But what we've just outlined here is how you work this out in a OpenCPN. To be fair, I should probably take one more problem and just work it without talking to show how fast it goes, but maybe I'll do that later. But that's the end of the video for now.